Assalamu alaikum dear students. We are discussing exercise 9 and this 1.1, and today we are going to discuss question number 9. Now the question number 9 of this exercise is show that each of the following relation defined in the set A equals to x, where x is integer and this x is greater or equals to 0, less or equals to 12. Now the first relation defined in this set is OR, where OR is a set of all those ordered pairs AB such that mod of A minus B is multiple of 4, while A belongs to A, B belongs to B. And the second relation is OR equals to set of all those ordered pairs, that is ordered pair AB such that A equals to B. Now we have to prove that these are the equivalence relations on the set A, and we have to find set of all elements related to 1 in each relation. That is, we have to find the equivalence clause in which one lies. Now here A is the set actually subset of integers, that is A is simply in tabular form as 0 1 2 up to 12, because x is here greater or equals to 0 and less or equals to 12. So this means that A contains these 13 elements. Now the first relation is OR such that AB belongs to A, where mod of A minus B equals to multiple of 4. Now let A belongs to A, means A is any arbitrary element of this A. Then mod of A minus A is 0. Now you know that 0 is the multiple of 4 because 0 equals to 0 into 4. So by the definition of this relation, A belongs to OR for all A belongs to A. So here OR is the reflexive relation. Now let AB belongs to OR means that AB is any element of this relation. This implies that by the definition, mod of A minus B is the multiple of 4. Here mod of A minus B is multiple of 4 implies that mod of B minus A is multiple of 4, because A minus B is either, if A minus B is the multiple of 4, the difference is for B minus A is only in sign, but the sign is here we have this mod of B minus A, which is again multiple of 4. So this means that BA belongs to OR. Hence this was arbitrary element, so this OR is symmetric also. Now for transitive, we have elements of the form of AB and BC in this OR. This implies that when AB belongs to OR, mod of A minus B is multiple of 4. When BC belongs to OR, mod of B minus C is multiple of 4. Now we have to prove that AC belongs to OR. Now mod of A minus C equals to mod of A minus B plus B minus C. Now this A minus B is multiple of 4, B minus C is multiple of 4. So multiples of sum of two multiples of 4 is again multiple of 4, because by taking 4 common. So this means that this A minus C is actually the multiple of 4. When A minus C is multiple of 4 implies that AC belongs to OR. When AC belongs to OR, this means that this OR is transitive also. Now this is reflexive, it is symmetric, and it is transitive. So by the definition of equivalence relation, this OR, which is defined as AB such that A minus B is mod of A minus B is multiple of 4, is equivalence relation. Now here this set contains 5, and mod of 5 minus 1 is 4, which is multiple of 4. So by definition of this relation, 5 1 belongs to OR, or 1 5 belongs to OR, because this is symmetric also. Similarly 1 minus 1 is 0, so it is multiple of 4, so 1 1 belongs to OR also. Also 9 minus 1 is 8, 9 minus 1 is 8, which is multiple of 4, so 9 1 or 1 9 belongs to OR also, because 9 1 minus 8, 9 1 minus 1, 9 minus 1 is 8, or 1 minus 9 is also 8. So both are the multiples of 8, which implies that 9 1 or 1 9 belongs to OR. But there does not exist any element other than these three elements, that is 1 5 and this 9. There does not exist any elements in this A whose difference with 1 is multiple of 4. So this means that we have only 3 elements, that is 1 5 and 9 are the only elements in this A which are related to 1 through this relation. So this means that this set, this 1, 5, 9 is the required equivalence class which contains n, and to which whose to with each and every element of this given set is related to 1. Now the second relation defined on this set is OR equals to ordered pair AB such that A equals to B. Now you can easily verify that this relation is both reflexive, it is symmetric and transitive. Here we will find only the equivalence class which is related to 1 or to which this one belongs. Here given set is 0, 1, 2 up to 12. Now this relation is defined as ordered pair AB belongs to this OR when A equals to B. Here from this set there does not exist any element other than 1 to which A equals to other than this one which is equals to 1, because 1 equals to 1 is the only element in this or the member of this set which equals to 1. So 1 is related to 1 only, hence the singleton set 1 is the required equivalence clause which is related to 1 or to which 1 belongs. Similarly you can do the question number 10, because in this you have to simply form a general relation on any set which is sometimes reflexive or but not symmetric, symmetric but not this transitive, transitive but not symmetric and reflexive. You can do it by yourself. Now question number 11 is OR is defined in A where A is the set of all points in the plane. Set of all points means Cartesian points. Defined by OR equals to ordered pair PQ means P is point, Q is point in plane, such that distance of P from origin equals to distance of Q from the origin. We have to prove that this is the equivalence relation. Also here we have to find the equivalence clause which is related to the point P which is not equals to the origin means 0, 0. And we have to prove that this is actually the circle passing through this point P with center at origin. Now here relation is defined as on this set of all points as PQ, where distance of P from the origin means mod of OP, where O is the origin, equals to mod of OQ. Let P belongs to A, then distance OP equals to OP because P is same, hence PP belongs to R. So R is reflexive because this P is arbitrarily point. Similarly, let PQ belongs to R. This means the distance of P from origin equals to distance of Q from the origin. Or in other words, distance of Q from the origin equals to distance of P from the origin. Hence, by the definition of this relation, QP belongs to R also. So R is symmetric. Similarly, let PQ and QR belongs to R. This means that distance of P from the origin equals distance of Q from the origin. Now distance of Q from the origin equals to distance of R from the origin. From these two statements we conclude that distance of P from the origin equals to distance of QR from the origin. Hence PR belongs to R also. So from this we conclude that this R is both reflexive, transitive and symmetric. Hence it implies that R is actually equivalence relation. Now let P is any non-origin point, non-zero point, that is P is not equals to 0, 0, that is point this. Now if we consider all the points which are at the equal distance from the origin as that of P, then clearly all such points form the circle, because points on circumference means they are at equal distance from the origin, because radius is same throughout. So this means that all such points which are at the equal distance from origin as that of P forms or lies on the circle which passes through this point P as shown in the figure. So this is the required class of points to which P is related. So thank you.